Why do modern building codes no longer design structures the way engineers did 50 years ago? In today's lesson, we'll compare allowable stress design ASD and limit state design LSD, and more importantly, why modern codes prefer limit state design. Welcome to Kussitta CENG Solutions. By the end of this video, you'll clearly understand how safety is applied differently, why limit state design is more realistic, and where allowable stress design is still used. Let's start with allowable stress design, also called working stress design. Applied load gives calculated stress which are then compared to allowable stress. In ASD, we calculate stresses under service loads or working loads. Then we compare them to an allowable stress, which is allowable stress equals failure stress divided by factor of safety. For example, if steel yields at 250 megapascal and we use a factor of safety of 1.67, then the allowable stress is about 150 megapascal. As long as the calculated stress is below this value, the design is considered safe. Let's summarize the key characteristics of ASD. 1. It uses service loads. 2. It uses one global factor of safety. 3. It is simple and easy to understand. And 4. It is stress-based comparison. That's why ASD was widely used in older codes, and it's still common in timber design, masonry, and some foundation checks. However, ASD has important limitations. First, loads are uncertain. Dead load is predictable, while live load is not. Wind and earthquake loads are highly variable, but ASD treats all loads the same. Second, materials behave differently. Steel is ductile, while concrete is brittle in tension. Yet ASD uses one safety factor for everything. This is where limit state design comes in. Limit state design is the modern design philosophy used in most international codes. Instead of one safety factor, safety is applied separately to both loads and materials. In LSD, we check whether a structure reaches a limit state. A limit state is a condition beyond which the structure fails, becomes unsafe, or becomes unfit for use. Ultimate limit state ULS, this is about collapse and failure. Examples: structural collapse, excessive yielding, and buckling. We use factored load saw loads multiplied by load factors, and reduced material strength, that means dividing by material safety factors. Serviceability limit state SLS, this is about performance and comfort. Examples: excessive deflection, cracking, and vibration here. We use service loads and assume no collapse, but usability matters. To summarize, allowable stress design is simple and conservative, while limit state design is modern, realistic, and code-based. That's why most current codes use LSD. If this lesson helped you, like the video, share it with engineering friends, and subscribe for more practical structural engineering lessons. This is Kussitta CENG Solutions. Engineering made simple and practical.